Welcome back to our YouTube channel. Myself Rath. I'm here again with a very important chapter. It's lubrication analysis. In the previous chapter, we have discussed about the parameters for which analysis is required, like physical appearance, smell check, change in color, and viscosity. And we have also discussed about all these four checks. Prior to thus start this chapter, I just want to say an important thing about this channel. This channel is for all the engineers who are working as a fresher or having some experience in the industries. Because in this channel, you have seen that we are covering the various technical aspects, and also this channel helps you for the employment. As we are also uploading the videos of the employment, the vacancies in various companies. So I request all the engineers and who are the viewers of this channel to please subscribe this channel and share it as many as possible. So I just start this chapter, but I want to say something that in lubrication we have already covered the formulation of lubrication, the sampling process of the lubrication, and now we are going to discuss about the lubrication analysis. So as I have already said, this is part 2. In the part 1, we have already discussed about the test parameter, physical appearance, smell check, change in color and viscosity. In this chapter, we'll discuss about how to test moisture content in the lubricants, tan value, that is total acid number, and the NAS. The very important parameter is NAS. How to check, we are going to discuss. So first, we see moisture testing. Why moisture testing is crucial? Because after the contamination, that is the particle contamination, the second most destructive contamination is the water, because the moisture will result in corrosion in the internal parts of the gears or any equipment where the lubricant is used. In that, if in the lubricants oil, the moisture content is enough, then there is a chance of corrosion of the internal equipments like bearings, gears, whatever the internals, maybe housing also. So you see why it is important, because presence of moisture will result in corrosion of internals like gears, bearings, housing, etc. And what is considered as the second most destructive contamination after the first one is the particle matters. So presence of water cause various defects like oxidation, aeration, viscosity effect, and lesser additive performance. So we'll discuss it one by one. First is oxidation issue. You see, due to oxidation, there is a formation of acid, and oil thickness also increase, which in form of varnish and sludge formation. So viscosity also increases. So this is a very important parameter that we have to check whether the lubricant is oxidized or not, because due to this oxidation the tan value increases, that is total acid number. We'll discuss in the further slides about this. So if oxidation is less, the normal life of lubricant oil is around 5 years, and if this oxidation is not happening, the life of the lubricant is much more also. But during the process, during the process of the equipments, the parameter of the lubricants changes drastically. And if there is oxidation, then definitely the life reduces a lot. Life of the lubricant reduces a lot. Then the second most important thing is that the aeration leads to the forming or air entitlement. This is also due to the moisture. As the moisture is inside the lubricant, then aeration will happen, which will form the forming of the oil. Whenever you open any gearbox, planetary gearbox or any other gearbox, you must see there is a lots of foam in the oil and it's floating, and this will misguide you for the level of the gearbox or level of any equipment. So definitely this is a major issue. Then moisture also lead to stable emulsion, and hence viscosity will increase. As I have already said in the oxidation, that it will thicken the oil due to the formation of Bernoulli's laws. So the viscosity also increases. Due to moisture, the most important thing is that the performance of the additives deteriorated. Whatever the additive we have added as per our requirement of the lube oil, because as I have already said in the earlier chapters that lube oil selection is must as per the design of the equipment, because whether it is a high speed motor or high speed fan, high speed pump, or the load is more, then as per the criteria of the machineries we have to select the lubricants. So basically we have discussed here about the why moisture testing is important. Now we see how to check the moisture. There are different methods. I will discuss it one by one. First is by using calcium hydroxide. So in this method, what happen? Basically, a capsule of calcium hydroxide is added to the container where the lube oil is kept, and then seal the container and just agitate it thoroughly so that it will mix. And the moisture present in the oil are in the form of maybe free moisture, maybe emulsified moisture, or maybe dissolved. So we see how to eliminate that moistures. That is the different thing. By definitely we are using the LBDS machine to remove moisture from the equipments. But here you see in this method, by using calcium hydroxide, we just put one capsule of calcium hydroxide in the oil container and agitate it thoroughly, and then you see if free and emulsified water present in the lube oil, then hydrogen will be released. So see, if there is any free and emulsified water, then there is a release of hydrogen, and this release of hydrogen depends upon the concentration of the water. If the moisture is more, then the hydrogen release is also more. So this is one of the method, but nowadays none of the industry use such type of method. So the second most used method is it's a Crackle test. Crackle test is nothing but, if you see there is a hot pot and you just put some oil on that, and the hot pot is around 160 150 degrees centigrade, and you put some oil and there are some crackle sounds, the formation of bubbles. So more the water contamination, more will be the bubble formation. So crackle test, you see few drops of lubricant oil put on the hot plate, which is kept at a temperature of 160 degrees centigrade, and depending upon the concentration of the moisture, whether it is in free form, emulsified form, or dissolved form, as I already said, the quantity of bubble we can able to visualize. So this is basically a heat and trial method. If there is more water in the oil, then definitely the sound will be more, the bubble formation will be more. But we can't say the exact value of the moisture in ppm or ppb in the lubricant oils. So you see, next we'll discuss about the process which is the most used process in the industries nowadays. We are using Karl Fischer moisture test. So Karl Fischer developed such a device which is very known device at this point of time, is colorimetric moisture meter. And in this colorimetric moisture meter, what is most important thing is that there are two types. One is electrolysis, another is titration type, and I will discuss further. But you see, if the moisture is very high in the oil, as we know the water is heavier than oil, then it is very easy that you put the lube oil drum for some time. You can see in the drain water is coming first, then oil will come. So there is a separation of oil and water. But if the moisture is not high, but it is also very important to detect that, then definitely we have to uh, analyze the moisture by some methods, and Karl Fischer method is very important at this point of time, and most of the industries are also opting this method. So moisture testing can be done by visual check also. As I have already said, if the moisture content is high, it will settle down, you can directly drain. The most precise method to determine the amount of free or emulsified or dissolved water from the in the lubricant oil is the Karl Fischer moisture test. As I said, in this method we use the titration process. And this titration process is not like that we are adding some acid base and titrate that. No, not like that. It's something different, because here iodine plays a very vital role. You see, colorimetric moisture meter, this is the picture of the colorimetric moisture meter. Here there is a iodine generator, and the quantity of moisture present in the lubricants that will consumed by the iodine. So there are two methods basically. Either manually we put some iodine, so in this solution you see the electrolyte here, or there is a iodine generator. It generates the iodine for the consumption as per the moisture present in the oil. The former one, as I said, manually we put some iodine in the solution, then we see when the iodine totally adjusted by taking the by absorbing the moisture, then the reaction stop and it will give us the result. But this may be inaccurate, because there might have some moisture left which are not neutralized or which are not consumed by the iodine. So in colorimetric moisture meter nowadays we are using the agent which produce the iodine, and the iodine will be produced for that much time or that much amount, so that all the moisture present in the oil will be consumed. As soon as the all the moisture will be consumed, the generation of iodine will be stopped, and it will give you a calibrated answer result. So this is very important. Here in this colorimetric moisture meter, the principle is used in this is electrolysis and titration. And basically the sensitivity of this machine, the sensitivity of this equipment is very high. It can detect 1 microgram of water also if available in the lubricants. So highly accurate absolute method of determining moisture is Karl Fischer method, moisture test. And you all must be aware about this. And I just want to say something more about this test, that in this method, moisture concentration is measured by titration process. As I have said, this titration is with moisture and iodine. And the process is known as volumetric titration process. As I said, colorimetric process, then volumetric titration process. There are two types of method. We'll see the difference. The main difference between these two is that with the volumetric method, the titration in this titrant is added manually and it is tested in the burette pipette. But in the colorimetric, the titrant, that is the iodine, is generated. So this is the main difference in volumetric titration process and colorimetric process. So now we see this is all about the moisture testing. We have discussed about various methods, and the another most important parameter is 10, that is the total acid number. Total base number is also there, TBN, but in the oil normally the base is not tested, as acid number increases due to the process, due to the during the using of the lubricants. So tan testing is very important. Tan testing is basically, as we know, tan is nothing but the acid number. So titration is the only measurement where we use the potassium hydroxide to titrate along with the acid present in the oil, and there is a methyl oil indicator to know what is the available tan acid in the lubricants. So tan is the total acid number. This is the measure of lubricants degradation, because as soon as the tan number increases means there is a chance of corrosion of the internals. So tan basically measure the quantity of acid compound in the lubricant, which shows the corrosive tendency towards the metal available in the system. So it is very important because tan value shows the quantum of oxidation process occur during the service of lubrication oil, because how long it is used and how long the oil is being processed in the system, accordingly the tan value will increases, the acid number will increases. So basically, as I have said, the tan testing determines the acidity of the oil by neutralizing with 1 gram of acidic oil with certain amount milligram of KOH. So that's why its unit is milligram of potassium hydroxide per gram of lubricant oil. So you all should aware about this tan testing. We have already done in our engineering life, in our higher education, and the practicals, we have done the titration. So please, you must careful for the tan testing, because acid plays a very vital role in the destruction process of the gearbox and gearbox internals. So basically, corrosion inhibitors are added to protect the copper or tin or lead based wearing materials by neutralizing acids and sealing the surfaces from contact of acid and water. For that, we are adding some corrosion inhibitors, additives in the lubricant oils. And you know, dispersions are effective agents for water and acid also. So that's why we are using some dispersions also, or sometimes we are using the base nature detergents, which are basic in nature. So this will also helps to neutralize the acid and decrease the tan number. And as I have already said, we also, there is a number that is total base number that will show the alkaline of the lubricant oil. So this is all about the tan testing. Now the most important parameter is NAS. You know, NAS, there is a very old history in this, because First, the National Aerospace used this NAS testing for testing their lubricants of the aircrafts, aeroplanes. So from there only the name comes National Aerospace Standards, that is the NAS. And NAS is nowadays tested in various industries by basically two methods. One is patch method, another is particle count method. And patch method, there are some pictures that if the NAS is 6, the contamination picture will be like that. If the NAS is 10, that contamination picture will be like that. That means in some of the industries, though it is adapted, but it will not give you the accurate answer. Patch test. In next session, I will discuss about this patch test in detail. But here, I just want to discuss some particle count test. You know, as per NAS 1638, the cleanliness of oil lubricants can be represented by contamination size. Because what is the size of the contamination will will identify as the NAS value. So as per NAS 1638, the size range of the contamination they have taken in 5 types of range, that is from 5 to 15 micrometer size of the contamination available in the lubricants. It's 5 to 15, 15 to 25, 25 to 50, 50 to 100, and more than 100. And I'm just giving you one example here how you know what is the NAS of the lubricant. Whenever you are going to test this, you see this is the particle count, and here the NAS is 10. How you come to know the NAS is 10? You see there are 5 ranges: 5 to 15, 15 to 25, 25 to 50, 50 to 100, and greater than 100 micrometer. And whenever this test is conducting, the equipment will display the sizes of the particle, the contamination. You see here 5 to 15, 1,02,893 particles available in the lubricants. And I will show you in the next slide the table. 1,02,893 means NAS 9. And if 15 to 25 micrometer particle available in the lubricants, that is here showing is around 10,000, then the NAS is coming 8. So in this, you just see the 25 to 50 micrometer particles available is 4,164, which denotes NAS 10, and 50 to 100 also showing NAS 10. So we have to take the more figure only. So in the next slide you see this is the table. From this table you see we see the NAS of the contaminated oil from 0 to 12. And from this table you see if 5 to 15 micron particle available 500, then the NAS will be NAS 1. If it is available, see 1,28,000, then NAS will be 9. Like that, as the contamination size will grow, then the particle count is also less. You see 50 to 100 micron particle size, three numbers only if available, then NAS will be 1. And if it is 90, then NAS will be 6. So you should follow this table to calculate the NAS of the lubricant oil. And in most of the industries, we are maintaining the NASH less than 7, which is recommended by the OEM, by the machine manufacturer, that you have to use the oil below NASH 7. So this is all about the testing of NASH, tan and moisture. We'll again meet in the next session. Goodbye, and please like, share and subscribe our channel.